So after knowing the basics of MATLAB, now we are going to solve certain basic problems in MATLAB. Let us say if I want to have zeros assigned to a 2 by 2 matrix, I will simply write zeros 2 by 2. Similarly, identity matrix 2 by 2, we will use a command called as I. Now if I want to add the zeros and 1 and store it in a variable called as C, I will simply write C is equal to A plus B. That is as simple as this. I will write here A, this is my matrix, A is equal to zeros, this is my 2 by 2, so all the elements would be assigned as 0. Similarly, B is equal to 1s. So for addition, the necessary condition is both the matrices should be same, so I will write C is equal to A plus B, and you can find here all the elements have become 1 1. Now if I'm writing here D is equal to I 2 2 means it is an identity matrix, and if I write E is equal to C plus D, so now you can find here what will happen. What is the value of C is 1 1. C plus 1 plus 1 is 2, 1 plus 0 is 1, 2 1 1 2. So this is how you can use ones and zeros conveniently. Now let us move to a interesting operator in MATLAB which is called as a colon operator. So colon operator is nothing but it is used to increment. It is called as an increment or a decrement operator. What does it mean? Whenever we want to increment or decrement a variable, say I want this variable 1 to 10. So what we write in the matrix is we write 1 2 3 4 5 6 7 8 9 10. So instead of writing all this element, what I can do is I know that there is a constant increment in between this number. So it will start from D is equal to 1 and it ends with 10. So I will use a colon operator here and will end it. So 1 is to 10. The default increment it takes when you do not mention it is 1. If you want to mention the default increment, you can write like this. D is equal to 1 is to 2 is to 10. So what happens is 1 is my initial element, 2 is my increment variable, and 10 is my last value. So you can see 1 plus 2 3, 3 plus 2 5, 5 plus 2 7, 7 plus 2 9, and 10 is my last number. So this is how the colon operator works. Colon operator is also useful in addressing certain rows and certain columns, and also certain elements from what range to the other range. For example, let us say I am having the matrix A is equal to 2 4 6. I am separating this row by semi-comma 8 10 and 12, and this is my matrix. Now if I want to address this matrix or say vector, you can name it as you wish. What you will write here is A bracket. I want to address all the elements of the first row. So what I will write here is first row and all the columns. I want to address all the elements of the first row. So columns, how many columns? 3 columns. So all 3 columns should be printed, but only with the first row, right? So what I got is all the elements of the first row. Similarly, if I write A 2 colon, it will print all the elements of the second row. Now reverse way, if I want to print all the elements of the first column, what I will do here is I will use colon operator here and first, right? Now if I want all the operators of the rows and all the operators of the column, I can simply use colon. It will give all the elements. This is how the colon operator is very useful in addressing the elements. Now let us again write the column. I will clear the space So once you have known what is the use of this, I will again write a matrix 1, 2, 3, 4, 5, 6, 4, 5, 6. Now let us find what is the maximum value in the first row and the maximum value in the second row. So there are two elements to this. Understanding what is the memory preferencing in MATLAB. Memory preferencing is first precedence to the column and then to the rows. What does it mean? It means my first location is 1, 1, then 1, 2, like 1, 4, 2, 5, 3 and 6. It is not on the horizontal, it is in the vertical side. Now let us say I want to find a maximum number, maximum value in each of the rows. So if I write here max A, it will not give you the maximum value in the row because the precedence of the row is second. So it is finding the maximum value in the row in the columns. You can see 4, 5, 6. These are nothing but the maximum value in the column. So in order to find the maximum value in the row, you have to write A, comma, this window and then 2 because the precedence of row is 2. Why this is used? This is called as the scanning of the whole matrix and the precedence of the row is 2 seconds. So that is why we are using it. So now you have found what is the maximum value in the first row and maximum value in the second row. Now let's clear and go to the PPT. So we have explained this one, how you can address or how you can find the values using the colon operators. Now if I want to find the length of a particular matrix, I will simply use length of A. So it will give you what is the length of A. So what was the length of A here? If I write here length of A, it will give you the length. It means it will give only the column size. If I write here, comma 7 and here I write comma 8 and if I write length, so you can find it is giving you the size of the column. Now suppose I have to find the size of the matrix, so I can write here size of A. So you can see here what is the size of A is 1 by 5. So what does it mean here? Size of A will give you the size of the matrix. Now let us go and see how do you multiply the matrices. How you multiply the matrices is nothing but a simple multiplication sign if you put. Let us see here. My A value is 1, 2, 3, 4 and B value is, again I am writing here 2, 4, 5, 6 and if I write A multiplied by B, C is equal to A multiplied by B, both the matrices would be multiplied. You can check out whether the multiplication is. But the difference is if I want to multiply each element by element, I will write here A dot star. What happened here is 1 is multiplied by 2, so I got 2. 2 is multiplied by 4, I got 8. 3 is multiplied by 5, I got 15. 4 is multiplied. So each element by its own memory address is getting multiplied by that element. So that is the difference between dot and multiplication. But the multiplication is multiplying the matrices. So once we know what is the addressing, you can also solve various types of problem using the addressing. Let us look at the subarrays. So what is my element here? What is my third element? So simply what you can do is first, second, third. This is my third element. If I want to find what is my first and the fourth element, it will print this and this. So this is how you address a particular array. Now if I write here array 1, 1 is to 2 is to 5, what does it mean here is I will start from 1 to 2 and what it will do is from 2 to 5. That is 1 is to 2 is to 5 means what does a colon operator means? My first element. What is my first element is 1.1. Then what is my increment is 2. So I will jump to this value 3.3. And last value is this 5.5. Let us look. Yeah, look in the MATLAB. Say first value is my array 1 is 1.1 minus 2.2. You can either use a space or you can use a comma. Anything will do. Now what we intend to do is array 1. We are starting with the first element, we are incrementing the element, and we are finalizing. So whatever is a colon operator, it will print 1.1, 3.3 and 5.5. So this is how you can use MATLAB conveniently to solve matrix problem. You can also use some loops which would be covered in your theory classes. So the loops would be very useful in taking decisions. So the basis of the loops is once you understand the matrices etc., you also know the flow control of the program, you can be able to solve complex problem in MATLAB. The next command is the AND command. What does the AND command mean here is you are starting from array 3, 5 is to end. So which is my fifth element? 1, 2, 3, 4, 5. This is my fifth element. And what is my last element? So AND statement will go up to the last element. Similarly, in this array 4, it will start from my second element, that is second row and the AND element. So this is my first row. This is my second row. So second row is this. So it should print 5, 6, 7, 8. Then it should print 9, 10, 11, 12. Right? 9, 10, 11, 12. But what happens in the next one is 2 to end. So 2 means this is my column. So it should go from 2 to end. So it should print 6, 7, 8, 10, 11, 12. So let us see. I will simply copy this. Let us see. Array 1. First we need to clear the workspace. Clear CLC. Array 1 is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is my matrix. Now where we want to print is array 1. Array 1. We are starting from the second row. We are going to the end. Then we are putting single comma, simple comma. Don't put semi-comma. Then we are going to from the second column to the end column. So what is my second row is 5, 6, 7, 8, and from that what is my second column is 6. So it should print 6, 7, 8, 6, 7, 8, 10, 11, 12. 6, 7, 8, 10, 11, 12. That's it. Hope you enjoyed it. Thank you.